since we all are ready, you guys make me feel it, make me feel it. Class?
Yes.
Thank you. Good. Appreciate it. All right. So, now that we're all here and ready to go, graph the derivative of this function. Now, let's go by key points. Key points are right here. Now, one of you actually said something last time when we were talking about it, but we weren't ready to deal with that concept yet. So, concavity. I don't remember who said it the other day. That one? Okay, concavity, yeah, right? So, at that point right here, that's a concave down, isn't it? But, in a way, this is a maximum at this point, right? Good. Down over here, this is going to be a concave up, and therefore there is a minimum at that point, right? So in between my two concavities, I'm going to throw up some gang signs right here for you guys watching online. Okay? Wait, other way. Oh. So I have a concave down, concave up, and in between my two hands, my fingers are touching right there. Where those two touch, that is called my point of inflection. It's where it's changing concavity. And in this case, that is changing right here at 0, 0. Now, on a number line, so I'm going to try and do this kind of two-dimensional first. So I have some points at -2, another point at 0, another point at 3/2, and looks like there's a point at 3. Now, derivative refers to the what? Slope, right? Calculus. Everything that we're talking about is slope right now. All right, I'm going to do it again, just in case you weren't paying attention yesterday. So, it's me, Mario. There you go. All right, so got my little guy. He's running left to right, isn't he? So he's going along that line. So along that line, from negative infinity up into the point of -2. Is he going up or is he going down or is he flat? He's going up, right? So that is a positive slope over here, isn't it? So it's a positive slope right there. So all the way from here to here, all the way down, it's all positive slope, right? Okay. And what happens right here? Okay, the slope is 0 at that point. I'm going to use a purple. This is 0 at this point right here, right? And now, this is, if I'm looking at my little guy, what is the guy doing from -2 all the way down to 3/2? He's going down, right? But I kind of skipped over this point right here, but I'll come back to it. I know that all this right here is a negative slope, right? It's all negative slope. So in between -2, so it's a negative here, and it also is negative here. Now, on the other side of 3/2, what's he doing? Is he climbing again, right? He's going back up. There you go. He's going back up. So right here, I know at 3/2, it's going from a negative to a positive, right? At 3/2, it's going from a negative to a positive. And at -2, it goes from a positive to a negative. So the graph of my derivative, really wish I actually had like a dark green or something here. This lime green thing don't do it for me. So it is all a positive slope. So if I'm doing a graph, so this is my f prime. So right here it gets to a slope of 0. So that means this y value here is actually my slope. Wow, that just is not a very good color. Light tan. That one sucks too. That one? A little bit better. Okay, so let's do this one. So in my derivative, if I'm graphing the derivative here, the y value is not the y value anymore. The y value is the slope at a given x value. So when I did this, my slope is 0 at this point right here, right? Make sense or no? Okay, over here at 3/2, my slope is 0. It's changing from a negative to a positive. So 3/2 is right here. So my slope is 0 right there. Now, along with that, let's go ahead and all this over here on the left side is going to be positive, isn't it? It's all positive, so that means it's going to be, everything is going to be above my x-axis here. It's above the x-axis because above, it's all positive slopes. Now, if I'm looking at this, right, and think about my little man climbing up this right here. He's climbing, climbing. He is increasing. He's increasing, right? He's going up. Is it getting steeper, staying the same, or is it declining? It's declining. So I could say from here to here, he is increasing, and it's getting easier and easier, right? At a decreasing rate. Yes? So he is increasing at a decreasing rate. So it's going to look like this. So my slope is going down, but it's still positive. All this is still positive over here, but it's at a decreasing rate. So right here, if I were to say here, my slope is, what's that? I don't know, 4, whatever it is. It's going to be a lot higher anyway. So I would say my slope is 4, and according to this, my slope is 3, right? So at a decreasing rate, it's a positive slope, but a decreasing rate, because that's going down. Now from -2 to 0. From -2 to 0, this is, what's he doing? He's going down, right? So he's starting here, he's going down, and it's getting steeper and steeper, right? So up until this point, he is decreasing at what rate? Christian? Never heard of him. Why? Is he doing something special?
I don't know. I just got it.
You don't know?
Give this to you.
Okay, hey, never heard of the guy. Okay? I heard, actually, no, I did hear him. He's kind of a jerk. Yeah, so, anyway.
Okay.
Anyway, so, again, in between -2 and 0, he is decreasing at a increasing rate, right? So I could say that he is going this way at an increasing rate. But this right there is my point of inflection. That's the change in concavity. So the change in concavity tells me that since here he went decreasing at an increasing rate, but right here it stops. And he's still decreasing, but he's decreasing at a decreasing rate. Okay? Because it's getting back up to this point here where that's a zero. That's a zero slope, so he's going closer to that. So therefore, it's going to be like that. It's still negatives because he's still decreasing, right? But it's at a decreasing rate. Now right here, at 3/2, what happened right here at 3/2? He hit zero, right? Zero slope. Zero slope, and he's going from a decreasing over to a increasing, right? So if I'm talking about my little man here, my little man's starting to climb back up. So once he starts climbing up, that means that is a positive slope again, right? So therefore, right here is where it changes to a positive slope. Hopefully that made sense. Do you want the cheater's method? Cheater's method? No? No one wants cheater's method? Okay. Oh wait, that guy. That guy wants cheater's method. My function, my original function. What was my original function? See this right here? Is that an x cubed?
Yeah.
Okay. So cheater says f of x equals x cubed. So this is not the entirety of the equation, but it's the shape that I'm going to use here, right? It's the shape. This looks like it's an x cubed. It starts down here, it ends going up. If I were to take the derivative of that, that would give me 2x squared. What's that shape? That's a parabola, isn't it? So the shape is important to understand. So the x cubed is my original, like this. And then when I take the derivative, it goes from an x cubed to an x squared. So the x squared is the parabola. So just by knowing those two things right there, I should be able to identify what the shape should be. Then I picked out the key points on there, and I started talking about, all right, I have a positive, negative, negative, and over here at 3/2, it started going again into the positive realm. Yes? Questions, concerns, complaints, conspiracy theories? Yes?
You said when you take the derivative, find the derivative for x cubed and it's turned into 2x squared.
Should be 3x squared.
Okay, that was my question.
Yeah, because I'm kind of stupid today. I haven't finished my coffee. I'm only like not even halfway done. So, but thank you. That means that you're paying attention. I would throw candy at you, but I had to get rid of all of it yesterday because somehow the ants got into my desk. They didn't get into my snacks. Apparently, there was, when I inherited this desk, there was some Jolly Ranchers in there somewhere. They found those. It was pretty bad. Anyway, so yeah. Given the piecewise function, determine if f prime of 1 exists. Identifying where a function has no derivative. So first thing I'm going to do is I'm going to evaluate it. So for a limit to exist, what has to happen? Left side and right side both go to the same point, right? That's the limit. Okay, let's see what we got here. So at 1, so let's see, let's plug it in this part, top part here into 1. I get 1 squared negative 2 minus 4 is. Did that just do that? What the heck? That was just weird. Just randomly change colors. So I get a positive 2 there. Now if I plug in 1 to the other side, I get 1 squared, 1 plus 1 is 2. Yes? And the function also has to be equal at the point. Okay, so now it is equal at that point because I just plugged it in on both sides just to double check. Now, let's see. I'm gonna graph this because I want you to look at it and then we're gonna go from there. So if you got your guys' calculators, go ahead, pull those bad boys out. So it was negative 2x squared plus 4. And it says x is less than 1. My other side says x squared plus 1. Dang it. It's greater than or equal to 1. X there we go. So now we know that the limit exists, right? The limit came out to be 2. But we have a problem here. When we look at this and we look at the graph, as we're doing this, the slope of the left side is what? Looks like it's a negative, right? Okay, the slope of the right side is a positive, right? And exactly right there at 1, what is the slope on the point? Huh? There is none. Because you don't have a slope on a point. This thing is called a cusp. So it is the pointy point on the graph where we cannot get a derivative of that one because it is not going from like that. So we could go up to a 0, but the problem is I can't do that because the left side and right side, this is called a cusp. There is no derivative there. Because we can't find the slope of a point. Does that make sense? Because it doesn't go to flat, so I can't balance on top of that and be 0, but it just pointy on both sides. Does that make sense, Christian? You good? Okay. So because of that, it does not exist. So there is no derivative on a cusp. All right, how many more of these do we have? Okay, we got this. Here's the graph to go along with it. So the corner, that thing right there, is not going to work. So, how many more of these we got? We got a couple. Alright, so let's pick up the rest of this on Monday. We'll pick up right here on Monday. And then from there, we will finish up this assignment. Make sure you like, share, and subscribe. Hit that notification button. Support my channel.